Okay, so for this next little set, we're going to combine some modules, so we're talking about the same information throughout the whole thing. So we're going to start with Mixed Module Lesson 15, and what we're starting here is with the Pythagorean Theorem. And it's a famous theorem that is used throughout much of high school mathematics and college mathematics. You will see several proofs of the theorem throughout the year and have plenty of practice using it. We first want to start off by knowing what the Pythagorean theorem states. So we're going to start off with that, and you're going to want to write this down, lots of this stuff. So Pythagorean theorem. Okay, so the Pythagorean theorem states if the lengths of a right triangle are A and B, and the length of the hypotenuse is C, then A squared plus B squared equals C squared. And we're going to talk about that. So with the Pythagorean theorem, you're always going to have a right triangle. So here we have a right triangle, okay? And we're going to say this is A, this is B, and this is C, okay? The side across from A, this way, is side A. The side across from B is side B. And the side across from the right angle is C, the hypotenuse. Okay, so we're going to write this down. The legs are A and B. And they are the sides that come together. These are the legs. Side A and B come together and make this right angle right here. Okay? The hypotenuse which is the longest side, and is always C. Okay? So make sure that you know this. And before we move on to look at the proof of the Pythagorean theorem, we need to know some basic facts about geometry. So we're going to write a couple things down here that we need to know. 1, congruent triangles have equal areas. Congruent triangles have equal areas. 2, corresponding parts of congruent triangles are congruent. And 3, okay, the triangle sum theorem. Okay, and we can abbreviate that angle sum of a triangle. And all that means is when we're talking about right triangles, okay, so for right triangles. Nope, I didn't move that up, sorry. The two angles that are not the right angles have a sum of 90 degrees. Okay? So, for example, this one is 90 because they have to all equal to 180. These two angles have to add to 90. That's what this is saying. And then to abbreviate this, we'd say angle sum of right triangles. Okay? And so what we're going to look at next is called a square within a square, and I'm going to go ahead and turn the page so I have plenty of room to write. Okay, put it back up there. So this is a square, the darker square, within the larger square. Okay. The outside square has a length of A plus B. So this just means that this plus this equals the length. Okay. And the inside square has a length of C. C, 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 C. And on a square, all the sides are equal. So A plus B, A plus B, A plus B, A plus B, C, 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 C. Okay. So our goal is to show that a squared plus b squared equals c squared, is to prove the Pythagorean theorem. To accomplish this goal, we're going to compare the total area of the outside square with the parts that it is composed of. So we're going to compare the area of the outside square with the four triangles and the smaller square. Okay, so looking at the outside square only, okay, what is the area? So we're looking only out here. So the area of a square is the side times the side. So if this side is A plus B, and this side is A plus B, we're going to multiply those out. Okay? So the large square area will be A plus B times A plus B. And I'm not quite sure, I don't think you have, but if we multiply this, okay, we would do what we call distribution. So A times A, which is A squared, A times B, which is AB, B times A, which is AB, and B times B, which is B squared. So we simplify that to be A squared plus 2 of the ABs plus B squared. So that's the area of the total square. Okay? Are the four triangles with side lengths A and B congruent? So if we look at this, if this is B, this is A, this is C. B, A, C, B, A, C, B, A, C. So they all have the same side lengths. Okay, so they are congruent. Okay. To find the area of one of the squares, of one of the triangles, triangle area, we're going to take 1/2 base times height. So for the area of a triangle, it is, so this was side times side. This is 1/2 base times height. So 1/2 times A times B. So that equals 1/2 AB. Okay. So because these are all congruent, they're all going to have the same area. So this would be 1/2 a plus b, 1/2 a plus b, 1/2 a plus b, 1/2 a plus b. So if we add it together, 1/2 a plus b, and multiply that by 4, so the total triangle area would be 4 of these, 4 times 1/2 ab. So 4 times 1/2 is 4 times 1/2 is 2ab. Okay? So all of these out here are the 2ab, which we have in the middle here. Okay? We call the entire figure within a square within a square, but we want to make sure first that the figure in the center is indeed a square. So to do this, we need to look at the angles and the triangles. First of all, what do we know about corresponding angles of congruent triangles? Corresponding angles of congruent triangles are also congruent in measure. So, to show that, okay, this is congruent to this, is congruent to this, is congruent to this. Okay, this angle here is congruent to this angle here, this angle, and this angle. So all of the angles are congruent. Okay, so we know that the angle marks by one arc are congruent and the angle marks by 2 arcs are congruent. What do we know about the sum of the angles of a triangle? Okay, so we know that they're 180 degrees. So because these two are equal, the third angle, which is the right angle, will also be equal. What is the sum of these two angles? These two angles of a triangle add together to equal 90 degrees. Because this angle is 90, these two angles here add together to equal 90 degrees. Now let's just look at one side of the figure. We have an angle with a 1 arc mark, and we have an angle with 2 arc marks. So then this angle here, all three added together must equal 180. So if we put 3 arc marks here, okay, we would get the same thing here, right? These two added together plus this one have to equal 180. So this is equal. Same thing here, 1, 2, 3. Same thing here, 1, 2, 3. So when you have all the same arc marks, these angles, the 3 angles, are equal to each other. Okay, and because these two angles have to add up to 90, and these 3 angles are supplementary angles, or a straight angle, which equals 90, these are going to be 90 degrees. Because these two angles are the same as these two angles. So all of them together have to, these two on the outside with the 1 arc mark and the 2 arc marks add together to equal 90. This one here would, because it's a straight angle, would have to be 90 degrees. Okay? So that means that the side lengths, or the figure with the length of C, the small square, with the length of C, must be a square. So it's a small square with 4 equal sides because they're all C, and 4 equal angles because they're all 90 degrees. So the area of the square must be C squared. So the small square area would be side times side would be C squared. Okay. Our goal is to show that a squared plus b squared equals c squared. To accomplish this goal, we compare the total area of the outside square with the parts it's composed of. The 4 triangles, so that means that the 4 triangles and the smaller inside square. Do we have everything we need? So when we put this together, we're going to write this out. So here we go. So it says the outside square area, the large square area, equals the area before triangle area plus the small square area. Okay, so I'm just writing it out. And now what I'm going to do is I'm going to put the large square area, which is this, over here. So this is coming here. So a squared plus 2ab plus b squared equals, this is coming right here, 2ab, and this is going to come in here, plus c squared. Now, because we can combine like terms, we have 2ab on the left and 2ab on the right, so we can subtract 2ab on both sides. They kind of cancel each other out. So we have a squared plus b squared equals c squared. And we did prove that that is the Pythagorean theorem, using a square within a square. Now we're going to jump right on into your packet, and we're going to work through it together. Okay. So example 1, it says, now that we know that the Pythagorean theorem is, or what it is, let's practice using it to find the length of the hypotenuse of a right triangle. Determine the length of the hypotenuse of the right triangle. So, what we're going to do here is we have a side 6, 8, and C. So the side across from A, like this, would be side A. The side across from B would be side B. So we're going to work through this. So the legs are A and B, and the hypotenuse is C. So it gives it to us here, but we're going to work through it so you know what I'm expecting, what we're looking for. So you're going to write out the theorem every time. We're going to plug in what number we know A is. So A is 8. 8. And you're going to bring down the square. B is 6. You're going to bring down the square, equals C squared. 8 squared is 64. That just means 8 times 8. 6 squared is 36. 6 times 6, C squared. We're going to add together. So 6 plus 4 is 10, plus 30 is 40, plus 60 is 100, equals C squared. And this is just asking what number times itself is 100. So C would be 10. 10 times 10 is 100. So that is how we get our answer here. Now, we could do this another way, and I'm going to show you how to do that with example 2. So on example 2, again, we're going to go through this. We're going to determine the sides, and then we're going to work through the Pythagorean theorem. So the side across from A is 7. The side across from B is 3. So this is B, and this is A, and this is C. This would be our hypotenuse. Okay? So again, we're going to write out the theorem. A squared plus B squared equals C squared. A is 7. And I'm going to bring down my square. B is 3. And I'm going to bring down my square equals C squared. 7 squared just means 7 times 7. 7 times 7 is 49. 3 squared just means 3 times 3, which is 9, equals C squared. We're going to add these together. 49 plus 9 is 58, equals C squared. And then this is asking what number times itself is 58. There is no whole number times itself that is 58. So this is where we're going to use the calculator and the square root. Okay? So we're looking for a number times itself to equal 58. And to do that, Okay. We're going to work through this. We're just going to leave it there. We'll leave it there. So, c squared, so if we were to draw a square here on this hypotenuse, the entire area of that thing would be 58. To find the side, we want to know what number times itself is 58. And we're going to learn that later in the year. So for right now, you can leave it at this. Okay? For each exercise, determine the length of the hypotenuse of the right triangle shown. Figures are not drawn to scale. Okay? So across from A is 4. Across from B is 3. So we're going to work through this. A squared plus B squared equals C squared. A is 4. B is 3. We're solving for C squared. So 4 squared is 16. 3 squared is 9. And you want to keep that equal sign lined up like that. You don't want to move it around. You want to keep C squared over on the right, and you're going to keep A and B on the left. So you're going to add these together here. 16 plus 9 is 25 equals C squared. Is there a number times itself that equals 25? Yes. 5 times 5 is 25. Okay, we're going to do the same thing here. Switch up my colors. Across from A is A. Across from B is 8, which would be B. And we're solving for C, so A squared plus B squared equals C squared. So here we're going to have A is 11. We're going to bring down the square. B is 8. Bring down the square. C squared. 11 squared is 121. 8 squared is 64. Okay, we're going to add these together. So C squared equals 5. 185. And is there a number times itself that equals 185? There is not. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. So there is not a whole number that equals 185. So this is showing that the area of the square here, if we drew a square over here, an actual square, this area would be 185. Okay? And then to find this out, we'll do that at a later date. Okay? Number 3. So across from A is 9, which that would be side A. Across from B is 4, that would be side B. So A squared plus B squared equals C squared. So A is 9. We bring down our square. B is 4. We bring down our square. C squared. And if you notice, I keep my equal sign lined up. Make sure you're doing that. 9 squared is 81. 4 squared is 16, so this just means 9 times 9, which is 81. This means 4 times 4, which is 16. We're going to add them together. 6, 7, 97 equals C squared. There is not a whole number times itself that gives us 97. 10 times 10 is 100, and 9 times 9 is 81. So that just means that the area of the square on this side would be 97. Okay, I want you to do number 4 and 5 on your own, and then come and check it with me.